Simonetta, and thank you for spending some time with us of Geek of Health. My first question is related to your daily work. All of us which are not a part of the space programs feel that this field of work is incredibly intriguing and exciting, but probably we are not completely understanding how deep it is. Could you please describe what is your background and what is your daily work at European Space Agency?
Yeah, the question is quite interesting because the space activities overall are quite, let's say, a way of life, a way of living, meaning that when you are embedded in this system, there is no difference between what you do at work and what you do at home. Meaning that it's, let's say, passion you must have in order to follow what is needed must be high and must be kept high during, let's say, our professional life. Right now we have a huge international lab in orbit. The lab is called the International Space Station, and it's in orbit around the Earth at an altitude of 400 kilometers. And it's very interesting because we have 6 astronauts living there, and then we exchange crews every 6 months, even if we have also some overlaps. And it's interesting because, you know, we are learning how to live outside the Earth, so beyond the limit of our planet. And that's the main subject of what we are doing, and all the rest is linked to that. So communication, localization on the Earth, Earth observation, planetary exploration, everything is linked to that. And what I'm doing every day and every night is to be linked with this world, trying to coordinate on ground what is needed, having direct contacts with the astronauts on board, and also preparing for the future, mainly what we call human exploration of the solar system, which is, in our mind, the next logical step.
It is rocket science. It is a super science which brings man in the outer space, but as much as trained and fit as they can be, astronauts are always men with all their physiological limits. What is interesting to understand is how space, long-term flight into space affects the human body, and which problems astronauts face in their daily work on physiological side.
Yeah, you know, the main point is that we are used to gravity on the Earth. And as soon as you leave our mother planet, you have a different situation. You have a different situation in orbit, where you are in microgravity conditions. But planning to be with an outpost on the moon or on Mars or another planet, at the end, the gravity conditions are different. So we are not only talking about the microgravity conditions on the ISS, on the International Space Station, so in low Earth orbit, but also on other planets where the gravities are different. So if we really want to understand a certain number of physiological parameters of our body, studying them in low Earth orbit, so in microgravity conditions, is quite important. But what is important also is that from some scientific results we are getting from these experiments on board the ISS, we can really help on Earth the day-by-day life. Why? One of the main impact we have when we have astronauts living for not only for a few days, because for a few days it's quite easy then to to come back to the normal conditions. But when they are living for more than few weeks, and presently they are staying on ISS for 6 months, more or less, the fact that they are floating and not walking is as an impact not only on their bones, but also on their fluids, meaning their blood, but also fluids in general. And so, in fact, sometimes when you have astronauts reaching the space station at the beginning, mainly it's true all the time long, but mainly at the beginning, you see them really a little bit inflated. And the reason is that the fluids are not going down anymore in the lower part of the body due to gravity, but it's around the body. And this is also impacting the way in which the heart is beating, because clearly you have a different situation blood-wise. There is also a problem related to the spine, because, you know, without gravity, the spine is, I mean, all the astronauts are taller. And this is a joke that we are doing sometimes, because when you have already a tall astronaut, it's fine because he's taller and taller, but sometimes the astronauts who are not exactly the tallest in the world, they are very happy to be on the station, because they can show that they are taller to their wives or their girlfriends. But so, jokes apart, what is important to underline is that clearly the fact that the spine is longer, and if we study that, this can have an impact also on what we study on Earth with respect to the spine itself. And you know that the back pain and some of the problems with the various discs and the space between the various discs, which is being reduced when we get older, clearly can have an impact mainly on the aging population, and we can help a lot.
So you were mentioning a number of issues that astronauts are facing, and that this poses some medical problems, but also opportunities to study how physiology changes into outer space, and can give some insights about how to treat illnesses on the Earth. Could you please mention which programs are currently running to study medical conditions into outer space, which have an outcome on the Earth?
Let's say the medical area has been one of the main areas of study since the beginning of sending astronauts in low Earth orbit. This is not true only for the International Space Station right now. This was true also in other programs before that. Reason being that on one side we need to understand these processes, how this, let's say, the physiological parameters are changing for astronauts in orbit, because we need to understand how to counteract these effects for them. So first of all, we started to work on how to counteract these changes in order to have astronauts healthy in their activities in orbit. But on the other side, it's clear that if you have the same phenomena in orbit that you see then on the Earth, you can really and quite immediately try to use the same protocols we are using for them to the day-by-day life and with the population on the Earth. One is what we call ESBRI, which is the European Space Biomedical Research Institute. It's for the moment only a project. It's not yet a reality. But it could really be, let's say, the next logical step in biomedical advancements.
Simonetta, it is not anymore the time when governments are usually financing the space programs. One big example is the recent cut of the space shuttle program after of 30 years of activity, which has been the landmark program of space exploration across last years. In the same moment, we are growingly observing the private initiative. I will make an example with the initiative of X Prize or the rising up of initiatives like Virgin Galactic, privates which take the private initiative to make spaceflight. How do you feel about these initiatives, and do you feel that this could be the next wave of space exploration?
The situation is quite interesting and challenging right now, because I believe that the access to low Earth orbit, namely the orbits around the one in which the space station is right now, is becoming more and more accessible for private companies. You were mentioning Virgin Galactic or X Prize, and these are more related to suborbital flights. So the idea is to have citizens flying up to a certain altitude in order to be able to see that the Earth is a planet, is not flat, finally. And it's only a flight of about 20 minutes of microgravity. But then we are also experiencing some private companies, mainly in the United States, which are developing systems to be able to send first cargo missions to the space station, and after that, humans. Now, why this is possible? This is possible because NASA and all the other space agencies, we have helped the system to develop the key technologies to be able to go and to reach the low Earth orbit, but also to bring first goods and then humans back. Mainly NASA, but also the Russians, they have the abilities to do that. And it's becoming the right time now, at least for NASA, to look at the next logical step. And the next logical step for them, for NASA, so for government activities, funded activities, is the human exploration of the solar system, because this is the next logical steps, also in terms of research and innovation, because we have to consider and we have to outline the fact that government money need to be focused on, we need to be spent focusing on activities which are really bringing with them innovation for the day-by-day life. Now, clearly, at this point in time, if certain technologies are mature enough, the flourishing of private companies is quite normal. Let's have a look at what happened in meteorology. At the beginning, it was science, and it was fully paid by governments. Now, it's obviously private, and we are getting the results of that. Every morning, we can check the radio, TV, internet, and we can get information on a private basis, because these are private companies dealing with that. We can get information on the weather for today and 1 week from now. But this is a private-owned service. And I believe this is now the right time to start also with access to low Earth orbit with that. And NASA and the other agencies will have to focus on the human exploration of the space.
So the next step in space exploration is a mission to Mars.
Mission to Mars has been considered by all the main space agencies around the world as the next logical step. Personally, I believe that even if with the Apollo missions, NASA has been able to provide the world the evidence that we can go on the moon, we can spend a bit of time and we can come back. In reality, what we need is to learn how to develop and to maintain an outpost on the moon, because the moon is a difficult place to be. And also in terms of logistics, we need a bit of step ahead before going to Mars. Mars is far away. I'm always using the example that if you are on the space station, you can really and you have a problem. If you have a problem with an astronaut, in a few hours you can have the crew back on the Earth. So if they have a medical problem, it can be solved. I don't want to say easily, but still, it's manageable. But if you are on Mars, you have to consider that from the Earth to Mars, you need more or less 7 months to go there with the present technology. Then when you land on Mars, you need to wait more or less 18 months until the two planets are in the right position, one in opposite to the other one. And you need then other 7 months to come back, meaning 2 years and a half. And every small problem, psychological, physical, medical problem, must be managed inside the crew. So by definition, you need to develop some technologies in order to intervene if it's needed from remote. And therefore, the complexity of the mission is far beyond the complexity we are managing right now.
Okay. We were talking about a number of previous space missions like Apollo, like the Space Shuttle program. Not everybody knows how many of things that we are using all the day are deriving from space flight related research. Could you please make some examples about what you use every day we don't know is coming out from space missions?
It's a very interesting question, because I'm always saying that unfortunately, what we are doing, we manage space programs. We are always working 24/7, and very often we don't put the right attention in communicating what we are doing, and this is probably our fault. But I have to say that there are a lot of activities during the day that we do normally, which are linked to space assets we don't know anything about. And sometimes joking, I'm saying, why we don't we select one day all over the world and we switch off all the spacecrafts in orbit. And in order to have the population on the Earth understanding how space is important in their everyday life. Just to make an example, in our cars right now, we all have a GPS receiver, and in few weeks from now, we will have also the Galileo one, the European system. Yeah. And now for us, it's normal. It's normal that if we want to go in a place, we digit, we type the address on the GPS receiver, and we go where we have to go. But this is due to the fact that we have a constellation of satellites, more than one right now, and this is helping us to go where we need to go. But also communications, very often we use our cellular phone in very extreme environments, and this is thanks to constellations of satellites in orbit. But just to make one example to show how important has been space in our life, one of the main, the most famous, I would say, spin-off of the Apollo missions has been the fact that, Pampers for kids. Yeah. This has been a clear spin-off of space. Because the first astronauts, they discovered that they needed to be in this spacesuit for a lot of hours, and it was impossible for them to visit the toilet, because also the position was a little bit difficult. And so rocket scientists at that time had to find a solution. They found a solution, and it was an immediate spin-off. And now all the mothers and the fathers all over the world are very happy for that. So we should remember that when we say that space is not important for our life, it's only, if you want one small example, I could make a long list of that, but just to tell you that really space is helping us a lot. Probably we don't know enough.
Velcro is another example, as much as I know. Is that right?
Yeah, absolutely. Absolutely, yes.
So please don't switch off any satellites, because I'm using GPS for tracking my running every day. So please don't, if I can make a personal.
And then pay attention, because next year in London there is a huge sport event, and without satellites it would be very difficult to follow all the matches and everything. So it's really important for, I would say, all the population all over the world.
Okay. So what are the technologies of the future that we can expect to read about next on Geek of Health? We always see in science fictions movie like Star Trek or the like, things which have been realized on the Earth. But what of the things that you are imagining for the future are going to be realized in the next years as an outcome of space missions?
What is important to notice is that if we really want to advance in certain areas and in certain technologies, we need to invest. And we need also probably to define which are the main strategic guidelines we want to follow, because we cannot invest on everything, because this is the only way to slow down the process. If we stay around the biomedical advancements we would like to see, I can tell you something which is, in my opinion, quite important. And this is also linked to the advantage we can get from space on Earth. If we check which is the medical cost per year for hip fractures in the Western countries, is something close to 900 million euros per year, which is a huge amount of money. You can imagine what we could do with that. Without considering, let's say, the advantage for the aging population not being, let's say, any more in line with that. So clearly, also, if we consider on top of that we need nurse care at home for aging population in this situation, if we really spend money in this field, the amount of money which is needed, without considering the fact that we need to, let's say, to fund different fields. So what we should do, in my opinion, is to select 2 or 3 themes, and this one is, in my opinion, one of the first to be selected, and we spend the right money now. I believe that in 10 years from now, we can really change the world from this standpoint. It's not easy to do that, because there are a lot of different interests around that, but that's what we should do now in order to help population, and mainly the aging population, but therefore the overall system, the overall social system. So space can be really helpful.
This can be really of great interest to know for the general population, provided that most part of, especially European population, is growing older in the next years. So being aware that space programs are going to have such a huge impact potentially on their life as individuals can be a strong motivator in making pressure on the governments to fund this kind of programs.
Absolutely, and in fact, I'm fully convinced that there are two, let's say, 2 areas of 2 ages in the population all over the world that we should focus on. On one side, young students in high schools, because that's the moment in which they decide what to do for the future. So it's the right moment to have them getting passionate with space and with the, let's say, the spin-off you can get from that. and on the other side, the aging population, because they are really keen to see what they can get from technology. I see my father really interested in understanding if something we are doing in space can be helpful for him to live longer.
Okay. Okay, Simonetta, thank you for your time. It was incredibly interesting to talk to you, and best wishes for your programs in the future. Looking forward to talk to you again.
Okay, thank you very much.
Thank you. Bye.
Bye.